In the previous video, coordinate recovery check was performed and the baseline is processed to create vectors. Now I need to do a network adjustment to determine a best fit coordinate for the point office based on all the input vectors. So a least squares adjustment process is used to do that. It's launched from the survey ribbon and the adjust network button. And here we'll just go through an overview of the steps involved. There is a tick button here to tick all the possible constraint options in terms of points with control quality status. If a point doesn't have control quality status, it's not going to be available to fix as a coordinate constraint in the adjustment. You can fix in 2D and height for GNSS coordinates, lat longs and heights essentially. We know from the coordinate recovery check that the time between Blackpool and the other points isn't quite as good in the height component, so a decision would have to be made whether to constrain Blackpool up here with the height component in the adjustment or not, or whether to let the height float. Whatever decision's made, in this case I'm going to untick the height component for Blackpool. I'm going to hit adjust. The reason I'm constraining everything to begin with is because this is a series of vectors all converging on one position rather than a network of triangles. So I'll hit adjust. You can see the reference factor is quite high, so it's encountered more error in the adjustment than it was anticipating based on the input from the baseline processing engine and the default setup errors. Chi-square test has failed. It's possible to look at a network adjustment report at this stage to see what level the errors are at. So it's approximately 3 mil on the easting northing and about 20 on the elevation. And the error ellipse components are shown here, and the adjusted GNSS observations with their standardized residual values for each measured component, so azimuth, delta height and distance. But it looks like nothing is flagged as an outlier, nothing's flagged in red, so none of those standardized residuals are exceeding this computed tau criterion value. It's possible to go back and change the default standard errors to make them less stringent, or it's possible to reweight the input anticipated error prior to the next round of adjustment. So in other words, the amount of anticipated error can be scaled up by a factor to a point where the chi-squared test can pass. The default is to use the reference factor from the initial adjustment as the input to that, and that's done using the weighting tab and using the transfer button here, and that will scale up the anticipated errors by a factor of 2. So if I now adjust again, the network reference factor should come out close to 1 or 1. Chi-squared test has passed. It's possible to interrogate the network adjustment report again. In terms of coordinates and precisions, nothing should have changed too much. Just check there's no outliers. So yes, about 4 and 3 mil for the error ellipse. Clicking on the point will give a little graphical representation of the estimated error from the least squares adjustment. Tap OK to complete that adjustment process.